Assalamualaikum warahmatullahi wabarakatuh. My name is Muhamadamirulbinalias and my matrix number is AN190050. My program is BNG and my supervisor is Mr. Muhammad Asri bin Azizul. As a slideshow, my title project is Development of Eco-Idle Kit System. Okay, for the next slide, for the introduction, for my first point is what is the Eco-Idle Kit System? Eco-Idle Kit System is a start-stop system that can shut off the engine when it's in idle. For example, when we start at traffic or traffic signal, the engine will be automatically stop, and the engine will restart when driver press the pedal. For the secondly, eco-idle system is a technical solution to the problem of fuel efficiency. That means these systems are designed to minimize gasoline. Thirdly, to set up the system that have a few parts that include starter, battery, computer system, that's mean electric control unit, ECU, and other components that need to modify to enable this system. For the next slide is problem statement. Firstly, nowadays a large number of vehicles, including motorcycle, was stuck on traffic light and traffic jam for almost 2 minutes, perhaps even longer than that. During this start, the engine was running in idle while the motorcycle was not moving. So the process of idling resulting waste on large amount of fuel consumption. Secondly, process of idling produce exhaust emission that cause global warming and health issues. The increasing use of fuel and global warming has forced the automotive industry to search alternative solution as emission to internal combustion engine. And lastly, from data article, the trend show growth of CO2 emission to transport sector in Malaysia has increased in early 19s to 2012. And for the demographic graph, for the motorcycle CO2 emission is about 11%. Okay, for the research objective, firstly to develop low-cost data acquisition system that use an Arduino for motorcycle encoded kit application. What is the DAQ? DAQ is the process of sampling signal, convert it to digital values that can be recorded. That means we use Arduino IDLE to develop this IDLE kit system. And second, to simulate IDLE kit system using integrated development environment IDE software. Yang IDE kit system will use IDE software to simulate based on the parameter to start and stop the engine. And third, to analyze data acceleration and deceleration of motorcycle during development of IDE kit system. Then we analyze the acceleration and deceleration of motorcycle to test its functionality and reliability of IDE kit system based on the real road condition. For the scope of research, firstly is we use the IDE software to construct Arduino programming for EcoIDE kit system. Second, the EcoIDE was carried out using Yamaha LC 135. And for the thirdly, the experiment was conducted on actual road condition. Lastly, the development of EcoIDE kit system for motorcycle as a retrofitted type. That means we modified the wiring and add the component to attach at motorcycle. Okay, for the next slide is literature review. From the literature review, I have a few article uh, from the literature review, but I just take for important article that I present. From the literature review, this is the finding on their method and result from past researcher to develop on start and stop system. For first article, it used the throttle to depart and start the engine. Then it developed of an AC generator to their starter, and the engine is turned slightly in the opposite direction to enable the piston to have a good start. Okay, for the second article is it state that retrofitting a car with a start-stop system, and the start-stop system is increase fuel efficiency to a maximum. Okay, from that we conclude that the method to develop eco-idle kit system. So we use the throttle to depart and start the engine. Then retrofitting which eco-idle kit system is the best way to develop eco-idle kit system and attach to the motorcycle. Then eco-idle kit system is increase fuel efficiency as well. It reduce exhaust emission. Okay, for the third article, uh, For the third article, it uses a motorcycle shut-off device that successfully to turn off and turn on the motorcycle engine, and is using short message service (SMS), and it built using locally accessible resources such as Arduino Nano, step-down transformer, relay, and a switch. From that, we know that we have know the function of the component to start and stop the engine. And for the last article, it able to we have the finding that Toyota Crown is able to shut off the engine just 1.5 seconds after stopping, and spark plug supply has been cut off the engine. In order to start the engine, it continue the spark by make modification in wiring. Okay. From that, we conclude that the function of component that can use to develop eco-idle kit systems such as that third article is mentioned that the it mentioned the function of each component so that we can use as well to develop eco-idle kit system. Then the time taken to shut off the engine. We know that the Toyota Crown is able to shut off the engine in just 1.5 seconds. Then from this literature review, we have know their concept to shut off the engine and modification on wiring to shut off the engine and start the engine. For the methodology, this is the flowchart for overall project. The flowchart have been divided for PSM1 and PSM2. Okay, for the firstly, from the literature review, we could identify the problem to develop of eco-idle key system. Then we could identify the objective and scope of project. Moreover, define the parameter of experiment to conduct. After that, develop the eco-idle key system part of offline trial, which mean develop the prototype of eco-idle key system to test their functionality and easier to troubleshoot if get any problem. Then validate eco-idle kit system in offline trial before prepare the assemble part to attach to motorcycle, which means validate the eco-idle kit system was suitable or not to use. For PSM2, we have integrate the assemble part of motorcycle, which means the part that need to integrate to attach to motorcycle. Okay, from that, validate the eco-idle kit system with different condition driving. From acceleration and deceleration. Then analyze the result data to ensure that the eco-idle system was be able to use on motorcycle. And we can conclude that the eco-idle system is suitable or not and get the recommendation on the eco-idle system. Okay, for the next flowchart is flowchart of prototype eco-idle system. This flowchart is different with previous flowchart. This flowchart is develop of eco-idle system. Step of develop of eco-idle system. Okay, from the eco-idle system, the prototype start with the power source from power bank and LED is on mode. LED is indicate to the engine is start, and after that if push button press and the RPM reading is 0, the Arduino will be set to off in 4 seconds. That means that the engine is set 4 seconds to off. Okay, for to start the engine, the limit switch need to be pressed and RPM reading needs to be 0. Okay, from that Arduino will be set to uh, start the engine. LED is on mode that indicate the LED engine is on. Okay, this is the demo of prototype. This prototype have a LCD display to show the engine is stop and RPM reading, and Arduino Uno. Then we have your IR blaster, LED, and push start button. This prototype is for the engine to stop, and for the video, the limit switch, and for the LED is on. It means that the engine is start. Okay, for the vehicle preparation is the how the component set up to motorcycle. From the to start the engine, we attach the limit switch to the throttle grip. From the limit switch is as a input to start the signal, and the Arduino Uno have connect the relay to normally open and normally close. For the input when the limit switch is pressed, it and normally close to start the engine to the starter. Then the limit switch have an input from the infrared blaster. If RPM is 0, then the starter will be triggered to normally close to start the engine. Then to off the engine, we have attached the push start button to the handle brake. Then if the RPM is 0, it will be stop the engine, which modified the wiring at the ignition switch. Okay, for the parameters test for each checkpoint, for the test track, we had used road in Papago, which has 5 checkpoints. Each checkpoint has a different parameter to be recorded. For the parameter 2 and 4, we had test for the make a U-turn and make a sharp turn. Okay, for the checkpoint 1 to 5, we had test the deceleration and acceleration. And for the checkpoint 3 and 5, we test the picoscope to test the battery voltage of the motorcycle. Okay, for the first parameter, we had make a U-turn. Okay, for the make a U-turn, the motorcycle was right in slow speed and stop. Okay, from that, the engine was not automatically stopped because the Arduino Uno set to stop after push button press more than 4 seconds. Okay, for the make a U-turn, we had stopped for a while. Then it was not is less than 4 seconds to before we release the brake. Then from this experiment, for make a U-turn is successfully because the engine was not uh, automatically stopped. Okay, then we have made a sharp turn. Okay, for the motorcycle, we'll test to make a sharp turn in slow speed. For the motorcycle, need to hard brake to slow down the speed. Okay, from that, the engine was not stopped, although rather press the brake because Arduino Uno get input from IR Blaster sensor, which is RPM exceed to 0, so that the engine will not automatically stop. Okay, for the distillation result, we take the time taken for engine to stop. Okay, for the time response recorded to analyze the data that the eco-idle key system was stable or not. Okay, we know that Arduino Uno has been code for 4 seconds to stop the engine after we press the brake and RPM is 0. Okay, from this result, the nominal time response engine to stop is 5 seconds. It may take delay 1 second for engine to stop at the quick or slow. For the in checkpoint 3, the engine response time are 4.92 seconds, which is it hard brake. In hard brake, the engine response to stop is slower compared to normal brake. This means that the in hard brake, the IR blaster is get the reading 0 is faster than the normal brake. For the acceleration, we have the time taken for engine to start. Okay, for the engine to start, we have nominal time response engine to start is 2 seconds. For the checkpoint 4, the engine response time are 2.95 seconds. That is because the power battery from the motorcycle become weak to start. Okay, this result is the picoscope test. We take the reading for the battery voltage drop from the picoscope. Okay, from the ignition off, we had the reading 12.83 volt. Okay, from that we had the battery voltage drop to the 9 volt because the battery voltage had to power up the coil to start the engine. And then from the coil start to charge, the graph have the jerk from the before it climbing to the 30 volt, and from the engine running, the battery voltage is above to the 13 volt. For the engine to stop, the reduction of battery voltage to 12.83 volt, and it have a constant reading at the ignition off. Okay, for the battery voltage drop at checkpoint 5 is the same at checkpoint 3. Okay, from that we can conclude that the battery voltage is stable and got the same result as well at checkpoint 3. Okay, for the ignition off, the battery voltage is constant at above 12 volt something, 12 volt 12 volt, and the battery voltage drop to power up the coil before the engine start, and the jerking uh, is the jerk uh, before engine is running, because its coil start to charge, and engine is running is above 13 volt, and the engine stop, it get the battery voltage reduction, and it's constant to 12 volt. Okay, this is demonstrate of the co-idle kit system. Okay, for
Okay, point last, okay.
press
Break.
the throttle, rotate the throttle, and the engine will be automatically start. Okay, for the conclusion, for the first objective is develop low-cost data acquisition system that use an Arduino for a motorcycle eco-idle kit application. Okay, we can conclude that the objective is achieved successfully, and this project has been applied Arduino Uno to develop eco-idle kit system. Okay, for the second objective, the objective is achieved successfully because the eco-idle kit system has been programmed by IDE software to automatically start and stop the engine. Okay, for the third objective, the objective is achieved successfully because the task time response from acceleration and deceleration has been analyzed for develop eco-idle kit system. Okay, for the recommendation, firstly, the setup the input signal from brake lamp as input signal to stop the engine. That means that we not use the push start button as the component to stop the engine, but we use the input signal from brake lamp as input signal to stop the engine. That means if we press the brake, the input signal will be as a input signal to stop the engine. Okay, for the second recommendation is assemble the Arduino Uno and breadboard in universal board to minimize space bucket of motorcycle.